Hi there, welcome to Caltex Academy. In case you are new here, my name is Julius, and thank you very much for clicking on this video. To my academic stars, thank you very much for coming back to support this channel. If you are not an academic star, don't worry, you can just become one by clicking the subscription button here and become one of the academic stars. It's that easy. So today we're looking at on our board here ionic equations. And what are ionic equations? Ionic equations are short form of molecular equation. So how do you get ionic equation out of molecular equations? It's very easy. We have some term of rules that we need to follow in order for us to convert molecular equation into ionic equation. So in this video, I'm going to walk you step by step on how we can see that we write this molecular equation into ionic equations. So what are these rules that we need to follow? Firstly, we need to make sure that our equation is balanced perfectly. And if you have challenges on how to balance equations, don't worry, you have got covered. I have linked 2 videos in the description of this video here, or you can watch it somewhere here and also watch those videos before you continue with this video. And if you are good at balancing equation, then come closer. Let's continue with this video here. Now, the second rule of thumb is that we need to see the state of the compound we are trying to write its form in ionic form. So elements or compound can exist in any of the 4 states that we know. And what are these 4 states? We have solids, and we have liquids, we have gases, and we have aqueous. So I'm more interested in the aqueous. Aqueous is a state of a substance when it is dissolved in solvents. Solvent could be like ionic solvent like water, or organic solvent like carbon tetrachloride, and you can mention some of them also. So from here, you need to identify those compounds with a state of aqueous, and then you can break them down into their corresponding elements that form that compound. So those are 2 important rules we need to follow. Now with all this said, let's take a look at our equation number A, where hydrochloric acid reacts with sodium hydroxide to produce sodium chloride and water. So you can see the first 3 compounds of hydrochloric acid, sodium hydroxide, and sodium chloride are aqueous. So this one will break down into their individual component ions that will form for us the cations and anions. And cations are the positive ions, meanwhile anion is the negative ion. So the combination of this will make us to write easily the ionic equations. So here, let's start with hydrochloric acid containing 2 elements of hydrogen and chloride ions. So we can break it down here where we have hydrogen ion, and the state here is aqueous, plus the next ion here is the negative one called anion, and that is chloride ion, which is negative because we have here the atoms are 1 1. So we have here also its state as being aqueous from this parent compound. Now the next thing here, we can move on and we look at the next compound, and that is sodium hydroxide. So hydroxyl ion consists of 2 atoms of oxygen and hydrogen combining together because they're called radicals. Radicals always exist in pairs. So this one will form the hydroxyl ion and sodium ion to form sodium hydroxide. So let's copy it out here and we break them down as sodium ion, and this time it is hot ion positive plus hydroxyl ion, and hydroxyl ion is negative, so we have also its state as aqueous, and this takes us to the product side where we have sodium hydroxide also breaking into its component ions of sodium and chloride. So from this side we have sodium ion aqueous plus chloride ion, and that is negative anion. So water is liquid, remember, and we said liquids and solid don't ionize, and for that case we'll just simply maintain water like that. So we can add plus water as liquid. Now, having disintegrated them into their component hot ions and anions, the next step here is to check on the common ions on either sides of this equation. When you find ions that are the same, then you can go ahead and cancel them away. So we can see here that, okay, chloride ion is common on both sides, so we can cross this chloride ion with this chloride ion from the product side. Now again, we can see here that sodium ion, these hot ions are also the same on both sides, so we can also cross them out. So here the sodium will cancel on both sides. Now when you check around, there's nothing that is already common. And lastly, for us to get our ionic equation, we just simply need to write the remaining ions and whatever do not ionize to form our ionic equation. So here we can see that, okay, what is left is hydrogen cation aqueous and hydroxyl ion, which is anion, and anion is negative with also an aqueous state. So we can also use our arrow here to differentiate the reactant side from the product side. Now from this side we are left with only water, which do not ionize as before. And you can see here that this equation makes sense in that the number of elements from the left hand side are only two, that is hydrogen and oxygen. And also the number of elements from the product side are also two, that is hydrogen and oxygen. And it is balanced in a way that there are two atoms of hydrogen, and here we also have two atoms of hydrogen. Then there is one atom of oxygen, here there is also one atom of oxygen. And we can see that this negative and positive will come together to form a neutral compound of water. So this equation makes sense and it is our ionic equation. So let's move to the second part of this question here, and that is B. And here we have calcium chloride reacts with sodium carbonate to produce calcium carbonate, which is solid, and this is white precipitate, and also sodium chloride as an aqueous. So we can see here that this part here is solid and it's not going to ionize, and we have three of these which will ionize. So let's go ahead and also write them in terms of their ions. But remember, before we continue to write it out, we need to see that this equation is balanced. And how do you balance this equation? We just need to check on a few things here. For this, we need to look at sodium. Sodium has two atoms, and here is only one, so we need to place 2 molecules here so that it multiplies with this one to get 2 atoms of sodium. And by placing here, we have 2 atoms of chlorine, and here there are also 2 atoms of chlorine, and carbon here is 1, we have carbon 1, oxygen we have 3, we have here 3. Basically we have 1 atom of calcium and 1 atom of calcium here, so meaning our equation is already balanced, so we can go ahead and split these compounds with the state of aqueous into their individual hot ions and anions. So let's start with calcium chloride. Now from here, calcium chloride will break into 2. So the first one is calcium, and calcium will have these 2 joining up there and be 2, meaning it has lost 2 electrons. So the next ion here is the anion, that is chloride ion, and since there are 2 atoms here, we can place 2 before this chlorine, so we have there 2 chloride ions in an aqueous form also. And we are done with this, so let's move to the next one here. So the next one is sodium carbonate breaking into 2. We know also that these 2 will go up to this carbonate, and we shall be having sodium, and since there were 2 atoms of sodium, we need to place 2 before this sodium here, and is positive. It has just lost 1 electron in the atom's shell, so if you multiply these 2 by these 2 here, you'll obtain 2 hot ions, which will balance with the other 2 that will move up here, and let us put it down. So we have carbonate with 2 negative, and from here the 2 positive and 2 negative will combine them back to produce the same compound here, sodium carbonate. So we are done with this side. We can separate the 2 sides always by using our arrow here. So the next one here is writing this calcium carbonate, because it is solid, so it's not going to ionize. So we have here calcium carbonate, which is solid, and the next one here is simply molecules of sodium ions. Of course, the 2 will multiply this 1 ion here to make 2 ions in an aqueous form, plus 2 chloride ions, which is also in an aqueous form, and we are done with breaking these individual cations from these compounds. Now the next thing we are left with is to identify the common ions on either side of this equation. We can see that also chlorine is common on both sides, so we have also sodium that is common on both sides, and these are the only 2 cations and anions that will cancel. So simply let's write the remaining cation here, that is calcium, and with 2 plus the next one here is carbonate. This is anion, so we'll write here 2, and we have these 3 here with the state of aqueous. So also let's not forget with our line that will separate the 2 sides. So on this side we have calcium carbonate, which is solid in a form, and this is how we will write ionic equations from this molecular equation. So thank you very much for watching up to this time. See you in the next video. PISA